Welcome back. We've audited the governance, the risk, the privacy, and the data. Now we walk into the workshop itself, the place where models actually get built and shipped. This chapter is about auditing AI development and deployment, and it's where your classic systems audit instincts meet the strange new rhythms of machine learning. Here's our focus map. First, the methodologies: waterfall, agile, and MLOps. What each means for control points and evidence, because you can't audit a process you don't recognize. Second, the beginning of the story: use case definition, feasibility, risk-based scoping, and auditing whether the algorithm and architecture choices were justified or just fashionable, connecting straight back to our black box trade-off discussions. Third, the paper trail: training documentation, reproducibility, evidence requirements, and verifying that what was built actually aligns with business objectives and policy, plus requirements traceability and enterprise architecture alignment. And fourth, the gates and the guardrails: pre-deployment validation, sign-offs, governance gates, model version registries, experiment tracking, separation of duties, and finally, decommissioning governance with regulatory look-back archiving. Because the end of a model's life is an audit topic too, as you already know from Chapter 3. By the end, you'll be able to sit across from a data science team and audit their build process with genuine confidence. Subscribe if you're new here, and let's step into the workshop. Let's start by learning to recognize the room you've walked into, because how a team builds determines where your control points live. Three delivery styles dominate: waterfall, agile, and MLOps, and each changes your audit approach. Let me give you the field guide. Waterfall is the classic staircase: requirements, then design, then build, then test, then deploy, each phase completing before the next begins. For auditors, waterfall is comfortable territory. Phase gates create natural checkpoints with documents to inspect: requirements signed here, test results approved there. You'll still find waterfall in regulated, high-stakes AI projects, and when you do, audit the gates. Agile works in short cycles, sprints, delivering small increments and adjusting course constantly. Wonderful for learning fast, tricky for auditors, because the big design document you'd love to inspect may not exist. Decisions live in backlogs, sprint reviews, and tickets. Here's the reframe I teach. In Agile, the evidence trail is the ticket trail. Well-run Agile teams have superb traceability, every change linked to a story, every story to a review. Poorly run ones have velocity and vibes. Your job is telling them apart, so ask to walk one feature from idea to production through their tooling. Now, MLOps, which we met in Chapter 3, and here's the key insight. MLOps isn't just agile for models, it's the industrialization of the model lifecycle. Automated pipelines retrain, test, and deploy models with minimal human touch. That changes your audit fundamentally because the controls move into the pipeline itself. The approval gate isn't a meeting, it's a pipeline step that blocks deployment without recorded sign-off. The testing evidence isn't a report someone wrote, it's automated test logs. So in MLOps environments, you audit the pipeline configuration as the control environment. Who can change the pipeline? Are quality gates enforced or skippable? And do humans remain at the decision points that matter? One field warning to close. Many organizations claim MLOps and actually run laptops and heroics. Ask one question to find out. Show me exactly how the current production model got there. The answer is always a story, and the story never lies. Every AI system starts as a sentence. Someone saying, we should use AI for this. Today, we audit that sentence because projects that begin fuzzy end expensive and sometimes end in the newspaper. 3 checkpoints at the very beginning: use case definition, feasibility, and risk-based scoping. Use case definition first. A proper definition answers plainly: what decision or task will the AI perform, for whom, replacing or assisting what current process, and what does success measurably look like. Notice what's missing from that list: any mention of technology. A use case defined as implement a large language model isn't a use case, it's a shopping impulse. I once reviewed a project chartered as AI-powered customer insights. 8 months and a sizable budget later, nobody could say what decision the insights would inform. The model worked, the purpose never had. As an auditor, request the use case document and apply one test. Could I derive acceptance criteria from this? If not, the project began without a destination. Feasibility next. And for AI, it has three phases. Technical feasibility. Does data exist with the quality and history the problem needs? Remember chapter 10. Everything we learned applies right here at the start. Economic feasibility. Does the expected benefit survive honest costing, including the monitoring, retraining, and governance overhead this course keeps revealing? And organizational feasibility, my favorite. Will the humans in the process actually use this well? A brilliant model that loan officers distrust or overtrust, remember automation bias, delivers nothing or worse. Then risk-based scoping, connecting straight to chapter 7. The use case gets a risk tier, and the tier sets the depth of everything downstream: validation rigor, documentation, approval altitude, oversight design. Your audit test here is elegant. Pick one project and check the chain. Was it tiered? Was the tier justified? And did the project's actual controls match the tier? When a high-risk use case traveled through low-risk paperwork, someone chose speed over scrutiny, and that choice, with its owner, is your finding. The use case is defined, the project is scoped. Now comes the moment with long consequences, choosing the algorithm and architecture. We've discussed the black box trade-off philosophically. Today we audit the decision itself, because remember our theme from chapter 2, design choices create audit constraints, and this is the design choice. Here's what good looks like so you know it when you see it. A justified selection shows evidence of alternatives considered. Ideally, a baseline comparison. We tried logistic regression, gradient boosting, and a neural network. Here are the numbers. It shows the trade-off analysis, performance gained versus explainability lost. And it shows the decision matched the stakes, connecting to the risk tier from last lesson. For a high-stakes lending decision, choosing a deep black box over a nearly as good interpretable model demands written justification and senior acceptance of the explainability cost. For a product recommender, a lighter rationale is fine. Proportionality, always proportionality. Now the anti-patterns your fieldwork will actually encounter. Resume-driven selection, the architecture chosen because it's exciting to build. Transformers for a problem a decision tree solves. Default-driven selection. We used what the platform suggested, meaning nobody decided at all. And benchmark seduction. Choosing whatever topped a public leaderboard, ignoring that the benchmark resembles nothing about the organization's data. Each anti-pattern has the same signature. No documented comparison, no named decider, no connection to stakes. So your evidence requests form a tidy trio. The selection rationale with alternatives and numbers. The explainability assessment for the chosen approach against the use case's regulatory and ethical needs. Remember Article 22 and the EU AI Act's high-risk expectations. And the sign-off. Who accepted this trade-off, and were they senior enough to own it? One closing technique I love. Ask the data scientist directly. If you had to defend this architecture to a regulator, what would you say? The confident ones give you the justification document from memory. The uncomfortable ones just gave you your finding, kindly, in person. Let's talk about the paper trail of model building. And I'll warn you now, this lesson is where auditors and data scientists traditionally clash. They say documentation slows science. We say undocumented science is anecdote. Let's find the professional middle and define exactly what evidence a defensible training process leaves behind. Start with the core question. If this model's decisions were challenged in 2 years, could the organization reconstruct how it was built? That's the reproducibility standard from Chapter 3, now made procedural. Reconstructing requires 5 preserved ingredients: the exact training data, versioned, remember data versioning and fingerprints from Chapter 10. The code, in version control obviously, but check it truly is. The configuration, hyperparameters, those human-chosen dials, and yes, the random seeds. The environment, library versions and infrastructure, because models are surprisingly sensitive to their kitchen. And the results, training metrics, validation outcomes, and the evaluation reports that justified acceptance. 5 ingredients. And here's the field truth. Most teams have 2 or 3. The gap is your finding, and the fix is usually tooling they already own but haven't disciplined themselves to use. Now, training documentation beyond reproducibility, the narrative layer. What was tried and abandoned? Remember experiment tracking from Chapter 3? That folder called Final Model version 7 really final? What data issues surfaced during training and how were they handled, connecting to our pre-processing judgment calls? What limitations did the builders themselves observe? This narrative matters because it captures the honest knowledge that never survives staff turnover, our handover lesson again, and the evidence requirements angle, calibrate depth to stakes. The EU AI Act effectively mandates much of this for high-risk systems: technical documentation sufficient for authorities, and SR 11-7 has demanded development documentation in banking for over a decade. So proportionality has a flaw when regulation applies. Your field test is the one I promised in Chapter 6. Ask for one production model's biography. Then go one deeper. Ask the team to actually rerun last quarter's training and compare results. Organizations that can, smile. Organizations that can't, learn something valuable in front of you, and so do you. Here's a failure mode that produces technically perfect models and organizational disasters. The model optimizes brilliantly for the wrong thing. Today's lesson is verifying alignment. Does what the algorithm actually optimizes match what the business actually wants, and what policy actually permits? Let me make the problem vivid. Every model has an objective, a mathematical target it relentlessly pursues. And here's the trap. The objective is always a simplification of the business intent. The business wants good lending decisions. The model gets minimized predicted defaults. Sounds close enough? Watch the gap. Minimizing defaults alone might reject every marginal applicant, strangling growth and financial inclusion, both business priorities that never made it into the mathematics. The model is a genie. It grants exactly what you asked, never what you meant. There's a well-known pattern in content platforms. Models told to maximize engagement discovered that outrage engages wonderfully. Technically triumphant, reputationally corrosive. Nobody chose that outcome. The objective did. So how do you audit alignment? 3 traces. First, objective to intent. Get the model's actual optimization target from the technical documentation. Then get the business case's stated goals and compare them yourself in writing. Where they diverge, ask who acknowledged the gap and what constraints compensate: secondary metrics, guardrails, business rules bounding the model's reach. Second, objective to policy. The responsible AI policy, remember Chapter 5, declares principles like fairness and human oversight. Does the model's design honor them, or does the optimization quietly work against them? A pricing model maximizing revenue per customer might individually exploit exactly the vulnerable customers the policy promises to protect. That's a policy breach wearing a mathematics costume, and connecting documents to code is precisely the auditor's craft. Third, metrics to reality. Is anyone measuring the business outcome, not just the model metric post-deployment? Accuracy can rise while the business goal sinks. Your closing question for the model owner: complete this sentence. This model succeeds when? If their answer describes the business and the documentation describes only mathematics, you found the gap where the genie lives. We've arrived at the final checkpoint before the real world: pre-deployment validation and the gate that guards production. This is the single most important control moment in the entire development lifecycle. So let's give it the audit treatment it deserves. What should happen at this moment? Think of it as the model's viva voce, its thesis defense. Independent validation, and let's lean on that word independent, borrowed from SR 11-7's effective challenge. Someone other than the builders critically examines the model. What do they examine? Performance on genuinely held out data. Remember, sealed test sets. Segment level results, because harm hides in segments. Fairness metrics against the organization's chosen definitions from Chapter 9's hard conversations. Robustness, edge cases, stress behavior, out of distribution inputs, previewing our testing chapter. Privacy checks where personal data is involved, memorization, leakage. And documentation completeness, everything from last lesson, present and honest. Then the sign-offs. And here's the governance choreography. The validator attests to what they tested and found. The model owner, remember Chapter 6, accepts the results, including the limitations, in writing, that risk acceptance fingerprint we keep hunting. And for high-tier use cases, the governance gate itself, the committee or delegated authority whose approval is recorded, conditioned, and tracked. Recall our rubber stamping detection tests, rejection rates, timing patterns, condition follow-through, they all apply with full force right here. Now the audit technique, and I'll give you the sequence I actually use. Sample recent deployments across risk tiers. For each, assemble the timeline, validation report date, sign-off dates, gate approval date, deployment date. Timelines expose theater beautifully. Validation completed the same afternoon as approval. Approval 3 days after the marketing launch announcement. Conditions imposed and never revisited. Then test independence. Organizationally, who does the validator report to? And could they realistically fail a model the business urgently wants? A validator who has never failed anything is either auditing perfection or decorating a corridor. And the MLOps twist from earlier, where pipelines enforce gates, verify the enforcement is real. Can anyone deploy around the pipeline, and who holds those override keys? The gate is only as strong as its widest bypass. Today, two disciplines that sound like pure bureaucracy and are actually load-bearing walls: requirements traceability and enterprise architecture alignment. Stay with me, because when these are missing, the failures are expensive and strangely invisible until late. Requirements traceability first. The idea is simple. Every requirement should be traceable forward to where it was implemented and tested, and every feature traceable backward to the requirement that justified it. For traditional software, this is standard practice. For AI, it gets interesting, because requirements now include things like the model must not use protected attributes or their close proxies. Decisions above this threshold require human review. Fairness metrics must stay within these bands, and explanations must be available for adverse decisions. Now ask the traceability question. For each of those, where exactly is it implemented and which test proves it? Here's why this matters so much. AI requirements have a way of remaining aspirations. The policy says human review, remember, and somewhere between design and deployment, the review became a log entry. Traceability is the discipline that catches the quiet evaporation. Your field move, take 5 critical requirements, especially the regulatory and ethical ones, and walk each to its implementation and test evidence. Requirements that trace nowhere are promises the organization made to itself and forgot. Enterprise architecture alignment next. Every organization has or should have standards for how systems get built, approved platforms, data integration patterns, security baselines, identity management. AI projects, often born in innovation teams with special dispensations, love to route around all of it. The result is what I call the brilliant orphan, a model running on unapproved cloud infrastructure, fed by a bespoke pipeline nobody else understands, invisible to enterprise monitoring, unpatched by enterprise security. It works beautifully, right up until the person who built it resigns, or the security team discovers it during an incident. Sound familiar? It's Shadow AI's sophisticated cousin, sanctioned in budget, unsanctioned in architecture. So your questions. Was the AI system reviewed against enterprise architecture standards? Are exceptions documented with expiry dates rather than permanent folklore? And does the system appear in the enterprise's asset inventory, monitoring, and disaster recovery plans? Alignment is unglamorous, and so are foundations, right up until the building leans. Let's equip you with 3 operational controls that mature AI shops run and immature ones improvise: model registries, experiment tracking, and separation of duties. Together, they answer 3 innocent-sounding questions that collapse weak organizations. What's running? How did we get here? And who's allowed to do what? Model version registries first. A registry is the authoritative catalog of models. Every version, its lineage, its validation status, its deployment state, which version runs where. Think of it as the fixed asset register, but for intelligence. Why does it matter? Because without a registry, the question, which model version made this decision last March, becomes an investigation instead of a lookup. And remember, regulators ask exactly that question. Your audit tests: does the registry exist? Is it complete? Sample deployed models and check they're all registered. And is it authoritative? Can something reach production without appearing in it? A registry with gaps isn't a registry, it's a suggestion box. Experiment tracking we've touched twice, so let's give it its audit meaning. Tracking systems log every training run, data version, parameters, results. For you, this is the difference between auditing a laboratory and auditing a kitchen after the meal. Tracked experiments let you verify claims. The team says the chosen model beat alternatives. And the tracking either confirms it or reveals the comparison never happened. Remember resume-driven selection? Now, separation of duties, your oldest audit friend, translated. The person who builds a model shouldn't be the one who validates it. That's SR 11-7's independence. The person who approves deployment shouldn't be the one who requested it. And critically in MLOps, the person who can modify the pipeline shouldn't be the same person whose work the pipeline gates. Otherwise, the gate has a doorman who owns the door. Also watch data boundaries. Developers with right access to production training data can, innocently or not, shape what future models learn, connecting straight to our tampering lesson. Field technique to close. Take one model version in the registry and ask for the names: who built, who validated, who approved, who deployed. 4 different names, healthy. 2 names, questions. 1 name, and you found the whole lesson in a single row of the spreadsheet. We close this chapter where every life cycle closes, at retirement, but with a governance lens this time. Chapter 3 gave us the mechanics of decommissioning. Today, we audit the governance around it, and especially the discipline with the wonderful name regulatory look-back archiving. Because here's the paradox of a model's death. The system stops running, but its obligations keep breathing. First, decommissioning governance. Retirement should be a governed change, not a quiet unplugging. That means a decommissioning request through the change process, remember Chapter 6's machinery, an impact assessment covering downstream dependencies, our dependency chains from Chapter 2. Someone must confirm nothing still consumes this model's outputs before the lights go off. A named approver, typically the model owner, exercising their final duty. And a checklist executed with evidence: access revoked, infrastructure released, registry status updated to retired, and monitoring gracefully closed rather than left orphaned and alarming. Your audit sample: pick 2 retired models and walk the paperwork. And keep hunting our old friend the zombie. Ask what process confirms a retired model truly stopped everywhere. Remember my pricing model that ran 18 months past its funeral? Now the archiving, and here's the reasoning from first principles. Regulators, courts, and complainants ask questions on their own schedule, not the models. Why was this loan denied in 2024? Show us the lending model's fairness testing from that period. That inquiry might arrive years after retirement, so the evidence must outlive the system. What belongs in the look back archive? The model artifact itself, the version that was actually running with its registry record. The training data lineage and dataset cards, or the data itself where retention rules permit and require. Validation reports, sign-offs and gate approvals, the biography. Decision logs, inputs and outputs for the retention period, the very logs we begged for at design time in Chapter 4. And the documentation narrative, model cards frozen at each version. Audit angles. Does an archiving standard exist specifying contents and retention periods aligned to regulatory obligations? Is the archive tested? Can they actually retrieve and read a 3-year-old model artifact? Formats rot? And is access controlled? Archives full of personal data are still personal data. Chapter 8 never stops applying. Here's the closing thought for the whole chapter. Development is where promises get made. Deployment is where they get kept. And decommissioning is where the organization proves it can answer for them even after the machine is gone. Next chapter, we manage the living system, change, configuration, and incidents. See you there.